Kia ora, it's Bill here. Hey, what I want to do is I want to have a look at how to make our microcontroller responsive and reactive to the real world. And I'm going to use that in the context of a switch on an input pin. Let's have a look at the simulator here to start with. I've got this switch and it's connected to D.4. Now it's a 1 at the moment. That means it's high. When I press the switch, it goes low. Now, in computer programming and microcontrollers, we call this active low, which means when the switch is activated, it goes low, rather than when it's activated, it goes high. So this is active low. Now let's have a look at the code over here. What's happening in our code is there's an if statement. So this is our conditional test to see whether the switch is, now notice, low rather than high. So when it's low, we want to turn on the LED in the next line. Otherwise, we want to turn off the LED. And then we're going to wait for 100 milliseconds. So let's just have a run of this code and see what's happening. So at the moment, the code is running and the switch is not pressed. In other words, it is not low. It is high at the moment. So if it's not low, it's not going to do this statement. It's going to do this one here instead, which is clear the LED. So we can just single step through this process. Let's have a look at this as it's stepping around. So at the moment, it's checking to see whether the pin is low or not. It is not low, and therefore it goes down and does this statement here. So this is this active low thing working. So we can step around. Now what happens when I press this switch? When I'm in the step mode, this will lock into a 0 position. And the next time it comes to the if statement, well, the input pin is now low. And so what's going to happen is that it's going to turn on the LED, which of course is what happens at this step of the program. So now we can just run our program and we can see what happens when we release the switch. When we press it, release it, press it, release it. You can see it going low when I press it, which means the LED comes on. And when I release it, it goes high, which means the LED goes off. Now that's all very well for the simulator. However, the simulator is not the real world. Let's go over here and have a look at what's going on in a real circuit. So what I've got here is I've got my nano microcontroller and I've got this little switch on the right-hand side of the board connected to pin D.4. And I, at the moment, can see that the LED is on. So there's something wrong here. Now, let's just investigate this to find out what's going on. I'm going to come over here. I've got my oscilloscope connected to D.4, and so I can see what's happening. You can see at the moment there's a little wavy line here, like this. It's not 5 volts. It's supposed to be 5 volts when it's not pressed. And when I touch this, when I touch this, you can see that actually I'm putting 5 volts on the circuit, and my LED is doing strange things. It might be on or it might be off. It's gone on at the moment. When I touch it, let's touch around my circuit a bit more, see if we can get it to, I'll reset it. No, so our pin is just all over the place in terms of voltage. And that's because it's floating. The input pin is floating. If I have a look over here on the simulator, I've got a little diagram that helps explain what's going on here. Let's have a look at the schematic first of all. So there's our push button switch, our TACT switch, it's called TACT, and it's connected to D.4 and ground. Now, here's a simplified schematic of what's going on inside our microcontroller. Of course, there's lots of internal digital circuits here, which are very complex, but actually using our understanding of electric circuit theory, we can model that input as simply a resistor. And of course, in our internal digital circuits, this resistance is so high, we can effectively call it infinity. In other words, this resistor doesn't exist almost. It's just infinite, open circuit almost. That means that this wire here is free to float around to whatever electric potential there is stray near it. And so if you have a look at my desk here at the moment, what I've got is I've got a piece of wire. At the moment, the electric potential of that wire doesn't exist. It's got no relationship to anything. But when I put my finger on it, it's actually going to connect to me and it's going to pick up my electric potential. When I release it, there won't be any electric potential on it. So the same thing is happening over here. When I come over here, I turn on, I do strange things to my circuit. I'm going to reset it. See if my LED won't even go off at all. It's just picking up lots of stray energy. Oh, there it goes. When I put my finger on it, it's going off. So there's some strange things going on because it's floating. So what we do in our circuit is over here in the simulator, I've got a little explanation of what's called a pull-up resistor. So the pull-up resistor makes sure that this wire can never float. It connects it to 5 volts. And effectively, this acts like a potential divider, except this is a high value of resistance, yes, but this is an even higher value of resistance, almost infinite. So that means that there will be 5 volts on this wire. So I need my pull-up resistor in the circuit. Now I can connect an external pull-up resistor, but these microcontrollers nowadays all have internal pull-up resistors. We just need to figure out how to activate them in software. Now in the simulator, when you connect a switch, what it's going to do is it's going to actually put in the code for the activation of that internal pull-up resistor. But of course in the simulator, it doesn't work like it does in the real world. Whether it's in there or not doesn't really matter. It's going to think about this as being 1 and 0. But in the real world, this matters. So in AtMouse Studio here, what I've got is I've got a piece of code, and here is my line which activates the internal pull-up resistor. I'm going to uncomment that. I'm going to compile it. So that build was successful. I'm going to plug in my programmer. There we go, it's plugged in, and I'm going to upload that program into the microcontroller. All done, thank you. Now you'll notice straight away that the LED is off and the voltage is showing as 5 volts on my oscilloscope. Now if I put my finger over here, nothing happens, okay? That's great, that means that it's tied to 5 volts, won't go anywhere. Now when I push the switch, this voltage here should go low, which it does, and the LED should come on. There we go, when I release it, the voltage goes back to 5 volts and the LED goes off. So this is my active low, 0 volts and 5 volts. Now, I hope this helps you understand a little bit about how to make a microcontroller responsive and reactive to the real world. In this case, I've just used a switch, though there are lots of other binary input devices that we could use in place of a switch to make it responsive and reactive to something else. Cheers.